Hi, my name is Christopher Catisse, and I work at the University of Utah on a U.S. Department of Energy funded research project called the Utah Frontier Observatory for Research in Geothermal Energy, or Utah Forge. Today, we're going to talk about the surface features or signs of geothermal energy. As a reminder, let's briefly talk about what geothermal is. Well, the word geothermal comes from two Greek words, ge or ye, which means earth, and thermos, which means hot. Geothermal is literally the heat beneath our feet. You see, the deeper you go into the earth, the hotter it is. In fact, Earth's crust averages about 60 degrees Fahrenheit. But just below that, in the mantle, temperatures range between about 1800 and 6700 degrees. But that's nothing compared to the outer core, where temperatures reach upwards of around 8100 degrees Fahrenheit. And in the inner core, the center of the Earth, you can find temperatures at about 9400 degrees. If the Earth's heat comes into contact with a gas or liquid like water, that transfer of heat is called convection, or cooler parts of the subsurface, that heat transfer is called conduction. The heat can travel to the surface, and when it does, we call it a surface feature or a sign of geothermal energy. So how can we tell when the Earth's heat has made it to the surface? There are a variety of geothermal surface features. The most common are volcanoes, geysers, hot springs, mud pots, and fumaroles. Let's take a look at each of those. Volcanoes. We're all probably familiar with volcanoes. You see, Earth's crust is broken into very large pieces called tectonic plates, which move very, very slowly on melted rock below the surface, which is called magma. Where the tectonic plates meet, magma is pushed up through the nearest openings, forming volcanoes and bringing the heat from the Earth's core to the surface. But did you know that the region around much of the Pacific Rim is home to about 2/3 of all the world's volcanoes, giving the area the name the Ring of Fire? Hot springs. Hot springs occur when water percolates deep enough in the earth to come into contact with very hot rock under the ground. If it circulates back to the surface, a hot spring is formed. For thousands of years, people have used hot springs for cleaning, cooking, and therapeutic baths. In fact, some of the best known hot springs around the world are used as therapeutic spas, including Bath, England, and Baden-Baden in Germany. You may have even visited lava hot springs in Idaho. Geysers. Geysers are a very rare type of hot spring that is under extreme pressure. When that pressure becomes too great, it causes steam and water to erupt into the air, usually at regular intervals. Probably the most famous geyser in the world is Old Faithful in Yellowstone National Park in the United States. But amazing geysers are found in many parts of the world, including in Iceland, Chile, and New Zealand. As a matter of fact, the most powerful geyser ever, Waimangu, was in New Zealand. No longer active, in the early 1900s, it was so powerful that it jetted water, steam, rocks, and mud up to 1,300 feet into the air. Mud pots. When hot underground water cannot make it to the surface, it can still produce a geothermal surface feature called a mud pot. Have you ever seen someone using a double boiler to melt chocolate? A pan with chocolate in it sits on top of another pan that is full of water. As that water boils, it gently melts the chocolate in the above pan. That's the basic idea behind a mud pot. First, water on the surface collects in a shallow depression. There is hydrogen sulfide gas found in the area, which causes that water to become very acidic. so it dissolves the rock and clay, making the water muddy. The hot subsurface water trapped directly beneath the depression turns to steam, which causes the muddy water to become a gurgling, boiling mud pot. Oh, the breakdown of that hydrogen sulfide also makes mud pots stink like rotten eggs. Fumaroles. Finally, we have fumaroles. These are vents in the ground that allow steam and volcanic gases to escape. The steam is from underground water coming into contact with magma, or the hot rock near the magma, while the gases are the result of the magma cooling down. The gases that fumaroles release can often be poisonous to people, animals, and plants. In very cold places, like Antarctica's Mount Erebus, ice towers can form around the escaping gases, and depending on the heat source, fumaroles usually only last for a few weeks after a volcanic eruption, but some can last for centuries or longer. There are still active fumaroles in Yellowstone, even though there hasn't been a volcanic eruption there in 70,000 years. Well, thank you for spending some time with me learning a little bit about geothermal surface features. There's a lot of information available online, and you can even find some pretty amazing photos. If you'd like to learn even more about geothermal energy and Utah Forge, visit our website at utahforge.com. Again, thanks for listening.